Hello, today we are going to learn Microsoft's Blazor, which is a framework for creating web applications and websites. It resembles ASP.NET MVC in the sense that it uses files which are using the Razor syntax and the Razor file extension. It has support for third-party libraries such as the DevExpress, third-party graphical user interface library. So for instance, this third-party library for creating web UI applications still supports ASP.NET Web Forms, still supports ASP.NET MVC, but also supports Blazor. Okay, we have two most important ways of rendering and running the web page. One is similar to a PHP website where everything happens on the server, and to the website just HTML, CSS and JavaScript is being sent, and then there might be interactivity using a signal R communication channel where the server is deciding what parts of the web page are dirty and is sending just delta. So a full page refresh is not necessary. The other way is client-side WebAssembly standalone. When your web app loads in a web browser, a small .NET framework is being sent, which is compiled to WebAssembly from the server to the HTTPS, from the HTTPS server to the HTTPS client, to the web server, to the web browser. And then this .NET runtime running inside of the browser communicates with the HTTPS server. It's downloading the rest of the .NET DLL as it were, and your application is compiled down to WebAssembler. So you can, for instance, serve most of your website from a purely static web server without any server-side dynamic source code execution possibilities. So just static files. Okay, let's go to the official website of Blazor and let's get started. So get started. Let's get started. We're on Windows. We're not going to use Visual Studio Code. We're actually going to use Microsoft Visual Studio 2022 Community Edition. If you're on Linux, you're going to use the .NET command line plus Visual Studio Code. On macOS, the same thing. And on Windows, you have the opportunity of selecting between command line and the Visual Studio Code, or only the integrated development environment, Microsoft Visual Studio 2022. We're going to use the latest version of .NET, so not .NET framework, but .NET, and that's version 8. I'm not sure what happens. So it says that I can see that this link is about Visual Studio 2022. It says in the status bar, and community. So probably this is the correct installer. Okay, so what we want is the free version of Visual Studio 2022. It's more than enough for us learning Blazor and following tutorials, the community edition. Okay, continue. It's going to download. It's going to launch a installer, this guy, where it already says Visual Studio Community 2022, and where we can select workloads and the individual components, etc. So let's have these two side by side, the documentation in the half right of the screen and the installer in the left half of the screen. Okay, so it says that we should select ASP.NET and web development workload, which is selected by default, maybe because that URL specified this. Okay, and that's it. Nothing else. Not Azure, not Python, not JavaScript, not C++, not UWP, not .NET Desktop, not games, not MS SQL, not nothing. Okay, that's probably it. And it's also selected the .NET 8 runtime. We probably need the SDK for software development kit for .NET 8. I'm just looking in here, but from the documentation, I know that I should not change anything in here in individual components. Although I see F# language, which maybe I do not want. Okay, so this should be it. I'm going to start the installing, so the correct components have been selected. I'm pressing the install button. It's going to download all of those packages, extract them, install them into the correct directory. Okay, so there's different versions of the Visual Studio installer. There's possibilities of installing other versions of Visual Studio 2022, such as Enterprise, and it has also the possibility of not installing versions of Visual Studio that are from the stable release channel, but from preview channels, other channels. We'll pause a bit until the installer finishes. So the Visual Studio installer has finished installing Visual Studio Community 2022. It has automatically started the integrated development environment. We're not using an account if possible. In here, I usually use Visual C++ because I like my shortcuts. So that's F4 for the next error, and the debugger is F5, F10, Control F5, F11, Shift F11. Okay. It's creating my user settings for Visual Studio. And now we're at the wizard where we create a new project from scratch. We can see on this page it says that this URL, this one, is configuring a download of the Visual Studio installer that will install this version of Visual Studio, so Community 2022, and it will pre-select the workload ASP.NET and web development. So there's less risk of people not installing Visual Studio correctly. Okay, this is it with this tutorial page. Continue. Says that we need to create a new project. Okay, all of the templates have been loaded in here. They're grouped by programming language, by operating system, and there's a search bar. In here we're going to write Blazor. Only 4 new project templates remain, and we're not going to use WebAssembly at all. So the template that we want is the first one, Blazor web app, the same. It's shown in here in the documentation. We go next. Configure your new project, Blazor app. Let me create a directory for the work. For that, I'm going to use my file monitor, my file manager. I have installed Total Commander. Let me configure it a bit. Letters only. Okay. And we're going to work in the directory, into the today's directory. So Blazor app, remove the 1. Additional information. Okay, that will be the next wizard page. So we go next. It has selected .NET 8 long-term support. Great. Do we want authentication? Do we want HTTPS? We could choose to only use HTTP during the tutorials. And for the newest version of Blazor and .NET 8, the option of having the entire website using Razor or the entire website not using Razor, you do not actually need to make this choice upfront. You can select one page to be using WebAssembly or one component inside of a page to use WebAssembly. Okay. I'll risk it and select the checkbox do not use top level statements. So we're just keeping all of the defaults, and I have additionally checked this checkbox do not use top level statements. Create. Now the wizard is creating the Visual Studio solution and CS projects. Okay, so this is the tool window in Visual Studio named Solution Explorer. You can collapse it, show it back again. This is the left-hand side tool windows. We have two in here. We have Git changes and Solution Explorer. Let me hide Git changes because I do not use it. There's a start page, a welcome page for the application, Blazor app overview. We do not need a Visual Studio What's New page. And I'm also going to clean up a bit the tool bar, the main toolbar. So I don't need the start window. I don't need a new project, open file, undo, redo, and finding files. Finding files is Ctrl-Shift-F. Navigate should be Alt and then arrows. So Alt left arrow for back and Alt right arrow for forward. For saving, I can keep just save all. It's advantageous to have as few buttons as possible in the main toolbar because when we're debugging, the additional toolbars might be shown in here, and if we're working in Visual Studio occupying just the left half of the screen, then the toolbars will be really crowded. Okay, so let's see. We're in Solution Explorer. We have a SLN file. How do we see this? So there's Blazor app.sln. Then there's a project inside of its own directory, Blazor app. The project is .csproj. And there's a entry point, which is this program.cs. Let's see what type of project this one is. So it's a console application, uses .NET 8 and is as agnostic as possible about the CPU instruction set architecture and maybe also operating system. So it's not specific to Windows. Okay. Program CS, let's look at it. So it is not using top level statements. It's looking more classic like this. It creates the universe and then it runs the main loop, which only exits when, I know, you closed all of the web browser windows or something. Okay, the entry point for the app starts the server, sets up the routing tables, has extra support for Visual Studio Integrated Development Environment Experience, debugging. I do not need this toolbar. This is called text editor. Okay, and then additional bells and whistles such as anti-forgery. Okay, and then there's a components directory with Razor files. The entry point is this one, the slash web page. There's routing tables which are not described in C# source code, but in Razor XML source code with actual Blazor controls, components, like this. So home sets just the page title and the route. And this is just a small part of the HTML that will be generated for the home page. The rest of the HTML that's going to be generated for the home page is taken from the other web pages. From this one, from this one, from this one. Okay. So app.razor is the root component for the app. Component is, when you say component, you actually mean Blazor and Razor syntax. app.razor, this guy, root component for the app. So this is the common part probably of web pages. The minimum common denominator. Okay. Routes. I don't like the fact that I need to scroll left and right. Let me fix that thing. Tools, options, and wrap. All languages, word wrap. And we might want to make the fonts a bit larger. Control mouse scroll. Okay. Layout, the default layout is the main layout. H1 selector. Program is this C# class, and type of program .assembly is the result of compiling this CS-proc, so a DLL or an exec. Let's actually see. Should be a .exe file. Okay, let's look at the CS-proc file. This thing, so it says that nullable reference types are enabled, and it's using .NET 8. So I'm not exactly sure what it restored. Okay, Blazor app is actually a DLL, although it's a command line executable console application. Okay, and it builds inside of the directory of the project of the CS-proc file, and then bin debug and the framework Let's go there. So this is the solution directory. This is the project directory, and the bin, and the build configuration debug, and then the target framework.NET 8. There's an exe, a DLL. And then in here it specifies that it depends on .NET 8, such that the .NET 8 DLLs are not copied into the output directory. In here it says that it depends on .NET 8. Okay, the pages directory contains the parts that are specific to just one page, so not a common denominator. There's a page/weather, a page/, a page for C# errors, C# exceptions, probably, and a page for /counter. Okay, can be viewed by double clicking. Can be viewed by double clicking. Yes, it can. Great. Otherwise, you right click on the CSProj file and go edit project file. Okay, then there's launch settings.json, which is where? Under properties. So on the file system, it's launch settings dot under properties, this guy. Inside the properties directory defines different profile settings for the local development environment. A port number is automatically assigned at project creation and saved on this file. Let's actually look at this thing. So there's support for running using HTTP protocol, HTTPS protocol. There's this is the .NET framework runtime, wherever running the application, the same thing. And in here you can host the web application inside of IIS Express. So the two web servers from Microsoft are IIS, Internet Information Services, and IIS Express. Okay, the port set are chosen randomly when the project is created are these ones. Okay, let's press the continue button. Says run your application. It has pre-selected HTTPS. So you can see in the launch settings file, the JSON, that we can run HTTP, HTTPS, and IIS Express. So we can keep HTTPS, and we'll need to select a web browser. Right now it's Firefox, but probably we actually want something better than Firefox and Microsoft Exchange, which is Google Chrome. Let me first make the mouse cursor bigger. Pointers and Windows default extra large. Okay, where are we? Let's install Google Chrome, but the MSI version. So we want the channel stable. We want an MSI and Windows 64-bit. We're not going to help. And how do we download? Yeah, the page is messed up because it's too narrow, the web browser window. So let's maximize. And now we have an accept and download button. Windows 64-bit MSI stable. Go. Let's put it into the same directory where I downloaded everything. Okay. It's an MSI. I didn't see any progress or anything. Let's see if it's already installed. Yeah, it's available. Okay. We want to make Google Chrome the default web browser and also tell Visual Studio to always use Google Chrome when debugging the website. Set as default web browser. Make Google Chrome your default. For file extensions HTML, HTML, and protocols HTTP, HTTPS should be fine. Okay, so that should be it. Let's restart Visual Studio. We're going to save, close the Visual Studio installer, and start the Blazor application by double-clicking on the Blazor app.sln file. We want to always use Visual Studio 2022, never the version selector. Okay, so it's loading. We want to debug the application, but using Google Chrome. Okay, so HTTPS, select the down arrow, and web browser Google Chrome, correct. Go. So this is actually debugging the application, not running it without debugger. So this is F5, not Control F5. Okay. Because we've selected that the page should be served via the protocol HTTPS, we will need HTTPS digital certificates. So we're going to use a self-signed certificate for now. Yes. It's going to add to the store of digital certificates in Windows the I don't know, a certificate authority or the actual HTTPS certificate. Do you want to install? Yes. IIS Express SSL certificate. Do I want to trust it? Yes. Okay. Yes, again. The application is building, so it generates DLL, exe, etc. It might also run engine on those or the equivalent, so a ahead of time or just in time compilation to native x86 64-bit. I do not use the tool window diagnostic tools, so I'm going to close it. Okay, so let's look again at components pages. So this error page is a special one because it's shown only when we have C# exceptions, .NET exceptions probably, or maybe in other, if other errors occur. So this is special, but then we have 3 pages, each on its route. So /counter, / and weather. So / is this guy, home.razor, and the tab home in the web browser. Then there's counter, counter.razor /counter, /counter. And the final one is weather.razor /weather. Okay. Weather shows a for each with HTML table rows. And before that, the rest of the HTML table. So a table header. Let's look at how HTML source code is combined with C# source code. So in here we have the start of a C# instruction. The instruction is if. Instruction starts here, ends here. So it's not a C# block, but a C#1 instruction. Whereas in here we have a C# block. So whatever is between these parentheses, these curly brackets. So this part is a C# source code block. So there's one class, one method, and a class member. A field. Let's see if we can actually see how this field is placed into an actual C# class, because I guess that this thing is just sugar syntactics. It's going to generate real C# source code, and then that thing is going to get compiled to MSIL. For that, I want to use ILSpy. Let's see if it works. This is the .NET decompiler that I use. Latest version. Let's download. What are the options? There's a zip file and an MSI and a self-contained zip. Let's go with the self-contained zip because this is also going to contain the needed DLLs from the .NET and maybe other dependencies. Okay, this I want to put inside of c:\temp\bin. Okay, it finished downloading. Let's go there. So temp bin, it's a zip. I have installed some applications, WinMerge, 7-zip. Let's extract. You can also extract because it's a zip with a built-in tool in Windows Explorer, which is this button, extract all. Okay, let's sort by extension. There should be few executables in here. There's just two ones, create dump and ilspy.exe. This is what we want, ilspy.exe. So IL is MSIL, Microsoft Intermediate Language. Okay, so let's make this thing use half of the screen. I have selected all of these strange assemblies. I'm going to delete them using the del button. And now I want to look at the generated source code, the generated C# assembly. So we have this source code line, which is going to be taken out of the weather.razor file because this thing, I guess, is just sugar syntactics. It's going to be converted into pure C# source code, and then that's going to be compiled into the DLL and exe from here. So these two guys. Let's see which of these. Blazor.exe, I'm dragging the file blazorup.exe to ilspy. ilspy complains that this is indeed a Windows DLL, so it's using the file format for Windows DLLs, which is called PE. So PE, portable executable, is a file format for Windows DLLs, has been used in all versions of Windows 32-bit, Windows 95, Windows 2000, etc. There's many possible extensions for portable executable files. The most common and known ones are exe and DLL, but there are also control panel modules, ActiveX, graphical user interface components, screensavers, Windows kernel modules, BIOS UEFI modules, etc. Okay, you know it's a PE because it has a the same header. Let's look at how it looks like. F3. So it always starts with uppercase M, uppercase Z, and then after some number of characters, it will say this plain text. This program cannot be run in DOS mode. And this is encoded 7-bit. So ASCII, not ANSI. Okay, the same thing for the DLL. This is also a portable executable file, but this one is managed. So a DLL for the .NET framework, whereas this one was built from, I know, C++ source code. So this comes from C# source code and this from C++ source code. That's why ILSpy fails to open correctly Blazor app.exe because it just does not contain MSIL, which then it means it cannot be decompiled from MSIL to C# source code. Okay, so nothing interesting into the Blazor app.exe file. I guess that this is just a file that exists in the .NET SDK, and it just gets renamed and maybe stamped with a version and a list of app domains and DLLs to load for the entry point. Okay, let's look at Blazor app.dll. There aren't any other portable executable files in here, so just the exe or the DLL. So it must be Blazor app.dll. Okay. We can select the C# programming language that we want. Says Visual Studio 2022 C#11. Maybe that's what we want. We can actually navigate our way around here, but there's no need to. The simpler solution is to right click on inside of the assembly tool window on the DLL, so Blazor in our case, and we go save code. And we're going to put the code in the today's directory in here. Okay. And it generates a CS proj that you can also open in Visual Studio, which we can do. Always. We should have two Visual Studio Integrated Development Environment applications open. One with a Blazor app that's still running, and the other one with just this CS proj file that was generated by ILSpy using as input this file. So it took this file and decompiled it back to this entire directory with hundreds of files. Okay. So we're in the file weather.razor looking for forecasts. We could just search, Ctrl+Shift+F, forecasts, match case, match whole world, find all, and probably also this entire line. Okay. So the sugar syntactics weather.razor is converted to pure C# file named weather.cs that contains on line 25 private weather forecast list and reference type nullable and then forecasts. Okay. There's this class weather forecast. Let's see where this is going. Not in its own class, in its own file, but inside of weather.cs, and even in here inside of the weather class. So this thing is part of the public class weather. This thing is part of the, where are you? Same thing, the public class weather. And what about this thing on initialized async? The same thing. Still a member of the weather class. Let's look at the source code. If something has happened, protected override async task or initialize the sync. Comments probably disappear when you compile the source code. So that's why ILSpy could not recreate this comment in here. And also new lines disappear. Okay. Start date is of type, which type? Date only. Also, ILSpy did not know when it decompiled if it should use var always, var when obvious, or var never. And it defaulted to var never. Okay, so this is the exact same source code. This thing is this thing. This is a shorter version of this. Okay. Summaries local variables have the same name. Then it goes forecasts. And this thing, enumerable range, is actually sugar syntactics over something. So when ILSpy decompiles the generated intermediate language, MSIL, it could go into this direction or into this direction or into other directions. So this is LINQ, and this is what is this thing? The two versions of LINQ. So this, which resembles the SQL structured query language of the databases, and this one which uses functions that always return types, such that you can chain the function calls. Okay, what about this thing? It's the same thing, so you could use inside of the function argument. You could have this block, or you could continue using SQL-like syntax from LINQ. Okay, so now we know that Razor code blocks get copied as they are inside of the class named as the name of the Razor file. So weather.cs file, and the class is named public class weather. Okay, but there's additional source code, which is this thing, this entire if. Let's see what this thing does. It's taken as is. So this part taken as is. This part is a Razor HTML style, which gets converted to this, so to a string, and then to such a line, which uses a render tree builder. Okay. Where is the else? It uses return early. So the else is actually this part. Okay. Builder table is this part, and then attribute class table is this part, and then t-head is all of this thing. So t-head, tr, th, date, end of th. It uses Windows style new lines, \r\n. Okay, everything ends at t-head and \r\n. And then these spaces are probably these spaces. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Okay. Then there's the body, which is closed somewhere. Nowhere. So open element will handle closing the element. So tbody and table. Here and here. Probably these two lines. So it's using a stack data structure probably, and it pushes on the stack a table, this part, and then it pushes on the stack the tbody, this part, and then when it says close element, it closes the top element in the stack, which is the tbody in here, and then it pushes the element that becomes the top in the stack, which is table, because when it closes one element from the stack, it removes it from the stack. Okay, so all of these things make sense. What about this component demonstrates showing data? Ctrl Shift F V. It's just, I'm going to guess that this method build render tree exists for all of the Razor files, which are of type page, which contain HTML style Razor, so this part. So let's see what it does. We're at the line loading. So this part, we did it. Then there's the paragraph, HTML paragraph. This component demonstrates showing data. This part. Then there's an H1, this part. And then there's one new line and two new lines, which are these two pairs of \r/n. And it says that this part. Okay, this is special. This is not HTML. This is not Razor. This is Blazor components. Page title, I guess. Where does it say weather? So this thing. There's a builder too, which is different from the builder that contains the HTML body. There's a second builder for the attribute child content. Okay, let's actually, so we have the source Razor source code, then there's the C# source code, and there's two more versions of the same web page. There's the HTML version, and then there's the human readable version. So let's run. Go to the weather page. Let's see if we can look at all of 4 versions of the same thing at the same time. Do we want the page source or do we want to inspect? Let's look at the page source first. So page source is the thing that the HTTPS server serves when the web browser navigates to a page and says HTTP get and then /weather in this case. So it's the initial source code of the web page. Okay, so we're interested where this weather title is placed on the HTML page. So we want this part, title, weather title. We want uppercase, case sensitivity. What is this thing? So we know how this behaves. It's just logical. It should be a h1 HTML. But then this thing is going to be more complicated because it didn't just say so this h1 appears twice. It's probably also part of this top menu, so the list of tabs. This is also an h1, I'm guessing, and this is also an h1. This is just styled using CSS. Let's prove this theory. No, it's not. This is a heading 1. Yeah, we should look at the source, the HTML source code in this instant of the page. So that's view page source, not view page source. Right click inspect, and then we want to copy everything. So right click, copy outer HTML for the HTML tag. Let me get a text editor. Let's use KD Kate. On Windows, nightly. I'm not sure if it's going to work. The 7-zip version into c:\10\bin, yes. Okay, let's give it a shorter name or not. I want to actually use this text editor, this guy, as the text editor when I use the F4 key in Total Commander. Configuration options, edit view, browse, and Kate. Okay. So now when I go F3 on a file, so if I select a file in the file manager Total Commander by clicking on it, I go F3, that's a viewer. This is an application that's built into Total Commander. And then F4 is going to open the file for read-write, for editing. When you open it with F3, it's read-only. Okay, so let's go F4. It's going to open the application kit. Okay. So this is how the source code looks at this instant. This is the instantaneous, instant, complete HTML source code. This is what's rendered in human readable format by the web browser, not the initial source code that you get by right-clicking and view page source, Control U. Okay. So the questions were like this: how many H1s are there? So there's H1 weather, and that's it, just one. That's why we only have one. Whereas in the initial source code, there were two of them. On lines 29 and line 44. Okay. And then these are important comments because they're used by the Blazor machinery in order to keep a score of which parts of the graphical user of the DOM of the HTML page should be re-rendered, should be refreshed, which are dirty, etc. Okay, so back to where we were. Where were we? The question was, how does the weather string get rendered as the title of the page, which we can see in the tab in Google Chrome as a text, and also if we hover on the tab, it's going to say weather. So that's part of HTML, head, and then title, weather. But then this is surrounded by start of BL19 and end of BL19. So this slash is the end of a tag, and everything is a HTML comment. So what's this BL19 thing? How can we see? Control F19. Well, it's not this one. Not easy to find out where this 19 is computed. Okay, so title weather is being set in here because that's the only place where it actually, where we have the string uppercase weather, except inside of the H1, and certainly not inside the H1 you set the title of the page. So this is the only place where it says this part, because it says open the Blazor component page title, the first item there, and then add an attribute, child content, which contains weather. Do we see page title? Nope. How can we navigate to the page title? It enables rendering an HTML title to a head outlet component. It's in the namespace Microsoft ASP.NET Core component. So Microsoft.ASP.NET Core.components is Blazor. The source code to Blazor is open source, available on GitHub. So you can actually look at this, at the source code of the page title. Let me actually do that. So GitHub Blazor, no, where is it? In the wiki. This guy. Okay, so let's look at the type, Microsoft ASP.NET Core Components. Probably this part. And then web. And I'm lost. Let me git clone this git repository and search using Visual Studio Code probably. Okay, so we have finished git cloning the git repository github.com/.net/asp.NET Core. So Blazor is, since a number of years, part of this monorepo for ASP.NET Core. We will get lost in here without Visual Studio Code, so let's actually install that too. Visual Studio Code. Accept. It's going to get installed per user, which is okay. Start menu directory. No desktop, no context menus. Register for supported types, add to path. Okay, so Visual Studio Code will be installed just for my user, and to the environment variable path, the directory where Visual Studio Code is installed is going to be added. So from all terminals or cmd.exe instances, I can just run code space dot and it will open the current directory in Visual Studio Code. How do we get started with Visual Studio Code? Next. No, thank you. Too much. Okay. So this is the Git repository of ASP.NET Core. We should be able to write in here code and then dot. Should open the Git repository, the entire directory in Visual Studio Code. And in here we can do search Ctrl Shift F. And we want to search for what? For this thing, page title. And now when I control clicked on page title type, it navigates to the correct place, but previously I tried and it did not work. So now it started working. What it does, it takes the DLL where this type is defined, Microsoft.ASP.NET.Core.Components.Web.dll, and it either decompiles the source code of the entire DLL or it downloads source code from some Microsoft server. Doesn't matter. Okay, so page title is a razor type defined in a namespace with dot components in its name. So this is razor, this is razor, this is razor, and this is razor because component. Okay. So it opens the element title, it closes the element title, and then inside this block, it puts whatever is the child content. Appends frames representing an arbitrary fragment of content. So not only text could put anything in here. Let's see if that's the case. So it says that it opens title, HTML tag, this thing, this. Then it puts whatever text or HTML parts are specified as child content in here. And then at close element, it's going to close the last opened HTML element tag. Okay. And child content is this thing. I'm not sure what attribute is. Okay. So back to where we were. There's 4 iterations of one razor file. The source code as you see it in your project. Then there's the C# version. Then there's the MSIL DLL. And then there's the initial HTML source code inside of the web browser. Then there's the instantaneous, the current HTML source code of the page in the web browser. And then that's the version that's currently displayed to the user by the web browser in a human readable format, which is this thing. Okay, so this is human readable, this is instantaneous, this is initial source code, HTML. Okay. And then inside of a razor file, we have just plain HTML. We have Blazor components, Blazor types. And then we have C# source code. These, and these, and also this. Let's actually look at 2 too short date string, this thing. So it says that it opened ER, it opened TD, then it put at the current place this C# source code evaluated. So forecast.date.toShort date string, which needs to be converted to string. But that string could be just a bit of text or could be entire HTML source code with HTML tags, etc. And then it says close element and closes the last one opened, which is this one. And then it says open element, this thing. And then it computes this C# thing, converts it to string, as it as content, closes the element last opened, which is this, etc. So right now we have a very complete idea of what actually happens in this long pipeline. Let's actually write down the pipeline, the complete pipeline. So there's a .razor file. There's a C# source code file. Then there's the DLL, this thing. And then there's the inside web browser initial HTML. Current HTML and human readable rendering. Okay, so 1, 2, 3, 4, 5, and 6. So this is it, the pipeline. Okay, back to the tutorial. Okay, so the tutorial says that you can debug an application. We can also probably run the application without a debugger. Then there's this feature, which is the hot reload button. Let's run the application in the debugger and see how the hot reload button works. So weather page. Hot reload. Hot reload on file save. Let's see if that thing works. Okay. So we want to change the H1 content to be the current weather. Control S to save. And it takes a while and it updates the web page. How does it do that? There's always a connection. There's a connection for debugging purposes between the HTTPS server that's being run. So it's a Windows console application in Blazor app.exe, which runs a HTTPS server that is part of the .NET 8 framework and as part of the ASP.NET Core framework and as part of the Blazor framework. And when we edit the Razor file, this is HTML. This gets saved, converted to C#, compiled to DLL, and then the DLL is probably reloaded, I'm going to guess. And then the engine that hosts the website knows how the DOM, the document object model, looks like inside of the web browser, and looks at how the HTML source code should look like based on the DLL, and then it talks to the web browser and says, hey, we have this delta between how the document object model looks like the DOM inside of the web browser and how it should look like. Please perform these changes. H1, the text of H1 should change from uppercase W weather and then to the current weather. All of these things, as you saw, took, I don't know, 10 seconds or something. It's a heavy pipeline, I'm going to guess. 21, 22, okay, 2 seconds. And there's this confirmation checkbox at the top left of the screen. This thing. Okay, so we proved that hot reload works. So hot reload could be you either press the button or use the shortcut Alt F10, or the way we did it, we enable the checkbox hot reload on file save. Okay, we can stop the debugging by pressing the stop button here, Shift F5, or from the main menu, debug, stop debugging. Okay, we have accepted the HTTPS development security certificate. There's an additional part in the web app which we did not see yet. Which is the about. This thing. So this is specified inside the Razor file for hello, for home, for slash. So home.razor. Only these things, an H1, a text and then the page title Blazor component, which sets home here, and the routing, and the rest, so this part with about and the left navigation tabs and the go to home page logo place or application name place. All of these are rendered from the rest of the pages, which are the layout ones. So there's the menu. Hot reload is still enabled. So we have weather, counter, and nothing. Let's make the first element, this home, go to counter also. So we go to weather, counter, weather, and then home also goes to counter. Okay, navlink is also a Blazor component. You can have this rule of thumb where inside of Razor files, things that look like HTML tags and are lowercase might actually be HTML tags, whereas these ones that looks like HTML tags but they're totally alien, don't resemble any existing HTML tag, and have Pascal capitalization, so C# capitalization for type names, such as navlink, is actually a component. And you can use the Visual Studio mouse hover to see what is what. This is how HTML hovering on top of HTML tags looks like, whereas this is how it looks like when you navigate on a C# .NET identifier. So navlink is a class. And control click on navlink will eventually navigate there. To the source code of navlink. Hopefully. Okay, so that was the menu. And then there's also main layout, which contains the top part of the page, including the about link that goes to a Microsoft website in a new tab. And then I guess the reload thingy or live reload is not defined here, but in some JavaScript library. Okay, so let's see what's next. The web page opens. Home.razor, we saw it. Page title component. Your connection is not private. We did agree to the certificate. Continue. Write the counter. Navigate to the counter app. Let's do that. Counter. The screenshots are older in the tutorial. There's a button. Click me. Let's see what it does. Inspect. So it's a button, btn, button primary, click me. Button. So button is an HTML input. Yeah, we'll see immediately. Okay. Increment the count without a page refresh. Incrementing a counter in a web page normally requires writing JavaScript. In Blazor, we never write JavaScript. We always use C#. You can find the implementation of counter component in counter.razor file. Okay, let's look there. Component counter.razor. Let's clean up a bit. Application insights, debug, location. Okay, we had 2 rows of toolbars in Visual Studio. Now we only have 1. Okay, so we're interested in the button. So this button is HTML button, class btn, btn primary, and there's magic. Magic says on click increment count. Then there's plain HTML, the text content of the button, and the ending tag. Okay, let's see increment count thing. Control click navigates correctly. There's a class, so there's a file counter.cs. There's a public class counter. This is a member of it. This is a member method of it. It's clear what it does. And then online, this one, current count, is just plain HTML plus magic. So this takes from this, the current class, an instance from the current object, which is an instance of the counter class, the value in the field current count, and converts it to string because it's integer. So it says current count and then a 4. Let's look back at the source, at the decompiled source code. So we want Blazor app components, pages, counter.cs, and we have the increment count method as is, as we expected. There's the private field as expected, and then this magic on click increment count. So says open element button and close it. So this part and this part. Then it says add one simple attribute, this part, and then add another attribute on click. So there's actually a one click on click in there, which I cannot see in the source code. Okay, on click, and then this C# source code. It creates a mouse event args of this and increment count, which is this method. Is there HTML on click? HTML button on click. Yeah, there is. It's a JavaScript function. Copy outer HTML. Control V. How do we put the language? Tools, highlighting, markup, HTML. The comments don't use numbers anymore, just the exclamation point. Where's this on-click thing? There's on-click for navbar toggler. And that's it. What does the button actually do? There's something magic going on, probably using JavaScript, but I cannot put my finger on it. I do not see where it is. Let's look at the source code of the initial source code. This thing. inside of the initial source code, we actually can see what's happening. So at this step, we can see that the button actually does something. The current HTML doesn't say anything interesting, but the initial HTML does show the reality. So button has this interesting comment in here. Blazor prepender ID, which I guess does everything. Type server. Server pre-render ID. Article class context. Blazor component state. Oh, Blazor server component state. All of the state is put in here in a huge string. So it's not evident to me because click me is a button, but I'm not sure if it's a HTML input because it doesn't do HTTPS operations, doesn't do a post or it's not part of a input tag. How can we see in somewhere the fact that I click? Does it do something server side or it's just JavaScript inside of the web browser? So these are the resources that are loaded in this page. There's Bootstrap from Twitter. The part at the end of the web page. This Visual Studio Browser link. ASP.NET Core Browser refresh. Hot reload support, ASP.NET Core Browser refresh. Socket, .NET Watch. From the command line, if you don't have Visual Studio, Microsoft Visual Studio, you only have Microsoft Visual Studio Code or your using the .NET command line tool in order to run the application, to compile it, to scaffold it, to generate it, etc., then the tool that you want is called .NET Watch in order to see instantly in your web browser the changes as you edit the source code. Deltas. Long polling. SCSS is CSS, so styling. The counter. What is a counter? A counter is a looks like the original HTML. Current count 0 and this Blazor ID pre-render ID for the button. More styling. Okay, so it's still magic to me what's happening when I click on the button, but we'll find out. Okay. A request for /counter in the browser as specified in the page directive at the top causes the counter component to render its content. So this counter.razor is a Blazor component, so a Blazor C# type. And that can be seen because it actually inherits from component base, which is one of the most important classes types in Blazor. So this is a Blazor thing, this is a Blazor thing, this is a Blazor thing. There's a render mode directive which says that it's not only generating the HTML source code on the server and then sending it as the initial HTML source code. It's not using WebAssembly, but it contains, so it's the web server generates the initial HTML, but there's additional magic via JavaScript and long polling HTTP and maybe using SignalR WebSockets. Okay, so the first line 1 in counter.razor is generated as C# source code in here on line 8. The class counter, which is a Blazor component, has the attribute C# attribute route /counter. Okay. The second line in counter.razor file, render mode interactive server, gets translated to the C# part, private component render mode, and mode impl is interactive server. Okay, next up. It says that when the current count is incremented, this guy, the entire component is re-rendered. So the component is all of this source code, what's in this page, the counter.cs. All of this gets recomputed, gets re-rendered as web browser document object model. And then the delta is computed between the previous state and the current state of the DOM, and just the delta is being sent. So in this case, that's the delta is that where is it? This. So on 8, it has increased, I know, from 1 to 2. So 8 was previously 1, the string 1, and now 8 is the string 2. That's the delta that's being sent from the HTTPS server to the web browser via either a HTTPS long pole or long connection or via SignalR WebSockets. Okay, continue. Add a component. Each of the Razor files define a UI component that can be reused. Let's go to home. Not here. Here. Home Razor already exists, was created by the scaffolder, the Visual Studio new project wizard. Is located in the solution folder components pages. Okay. Let's add a Blazor component counter to the app's homepage. So after the existing content, we add the Blazor Control S. So it's doing its things because hot reload on file save is enabled. And now if we go on home, there's additional functionality in here. Okay. So home.razor has changed this thing. Home.cs has changed. This Blazor component is being called and will be rendered and generated as HTML and then sent as delta because the home component has changed dramatically. It doubled in HTML source code. Okay, then it says that Blazor components have attributes, parameters. or can have children XML tags. Let's define a parameter on the counter component for specifying how much it increments with every button click. Let's go to the counter Blazor component. So the increment is being done in here. Plus plus means current version +1. And the Blazor component can be used in other pages using this syntax. Similar to an HTML tag, but inside we put the name of a Blazor component. So in here will be probably an attribute for increment amount. Okay, let's see what it does. Add a public property for increment amount with a parameter. Okay, this is a private field and we want a property, not a field. So public int increment amount. By default is 1, which is the current version, the current value. And then instead of incrementing current count always with 1, we can increment it with this value. Okay, it doesn't like something. Invalid expression term, semicolon. And that's it, it disappeared, the error. Okay, and we want this public property on the counter.cs counter class counter Blazor component to be exposed as a attribute in Razor HTML-like syntax. Let's see if parameter comes from Blazor. Yet it does. The namespace contains components. Okay, and in home we use this thing as similar to a HTML tag attribute. Let's see if we have auto-completion. Yes, we do. Increment amount 2. Control S. And it works correctly. Each time I click, it doesn't show odd numbers, only even ones. Okay. And the counter component is already used. Not really. In here. So this is both defining a Blazor component, but also using the Blazor component at this address. Very interesting. Okay, continue. You've built and run your first Blazor app. Keep learning. Blazor for beginners. A series of YouTube videos which we're going to actually follow. We will now follow the tutorial what is ASP.NET Core Web Development with .NET, this one, which is actually a YouTube playlist on the channel .NET. The name of the name of the playlist is Front-End Web Development with .NET for Beginners by Daniel Roth, and it's 11 videos. So let's see what it says. We did most of the first part of this video tutorial. Now we're at the conditional and repetitive structures in Razor syntax. On the home page, which uses the HTTP route /, we have added the presentation for another Blazor component, which is counter, which is this one. But we might have more than one Blazor components presented. We can also add the last one, which is the weather. Okay, so this is the Blazor component counter, and this is the Blazor component weather. Next up, in the counter, we will use the Razor syntax for conditional statements, so that's if, and we will put a P, an HTML paragraph, if a certain condition is met. So that would be if the current count is at least 3, then we put the P, you win, Ctrl S, navigate to the / counter, some changes require that you stop the debugger in Visual Studio and restart it, because hot reload cannot apply all of the changes. So if you're sure that your source code does a thing, but you cannot see that thing applied and available in your website, then what you should do is go to the Visual Studio main menu, debug, stop debugging, and then start debugging again. And then you can make sure that hot reload on file save is enabled. Okay, so we're going to the counter page, and this condition is when the count is, for instance, 4. Let's see if we can put a breakpoint in here. Okay, so strictly greater than 3, which would be 4. The breakpoint was hit. The debugger enters correctly .razor files. And this P is added at the end of the Blazor control. Let's look. So counter, P, button, and then another P, and everything is wrapped in a article. Okay. And as we keep clicking, the condition will continue to be true. More P's will be added. No, just one P. Let's look a bit at the C# source code. So I have just decompiled using ilspy the file blazor.app in the build directory of the Visual Studio project. So we have the build render tree, which creates HTML content, and then these two parts are here and here. Okay. So the last line in the Razor file that adds HTML is line 14, which is this one. Okay. And this is guarded by a if statement. If this.currentCount greater than 3, then builder add markup content you win AP. Okay, so that was a conditional statement surrounding HTML source code. Next up, let's use the Razor for repetitive structure. We'll have a unnumbered list. In here, we'll have a for. Okay, and items which say clicked. Okay, so the value of this.currentCount is 7. So this repetitive structure will add li clicked end of li 7 times from 0 to less than 7, which is 6. How do we refresh this thing? So it seems that hot reload doesn't actually build the DLL. So this one, blazor.dll. I needed to stop the debugger and then build the project. And then I can refresh in ilspy in order to re-disassemble blazor app.dll. In the namespace Blazor app component pages. So we have stop debugging saved and built the DLL. We refreshed in ilspy. We'll navigate to the correct namespace, which is Blazor app components pages, and then the class is named counter. We're going to look at the method build render tree. And at the end, we have the if statement for uwin and the ul this and closing the ul tag in here, close element. And inside we have the for loop. Okay. So if you have just HTML statements inside of a Blazor file that will get inside of a build render tree method of the class with the same name as the Blazor file, so counter, which is a Blazor component, will get added as a add markup content, or as a open element, or as a close element. And then the parts where we have inside of the HTML statement a C# expression gets added like this, add content and then C# source code. If we have an if, then the if will be put as is in the build render tree method, and the HTML will be added as expected using add markup content, add attribute, add content, open element, and close element. And then a for Blazor block will be copied as is, the for line, and then the body, which in this case is just HTML, will be added as usual. When you see these two side by side, the Blazor source code and the equivalent C# source code, it's easier to actually understand what is going to be the effect on the web page. Okay, so if you click once, the current count will be incremented from 0 to 1, will be written here, the current value of current count. And then if the current count is greater than or equal to 4, we will have this P, and we'll have as many unnumbered list items as the current count. So whenever I click on the click me button, the number of list items will increase. In the weather page, we already have both a if alternative statement and a for. Okay, so there's if, and inside the body of the then branch, there's a P with loading. This part. And then the for each is just copied as is. And the body of the for each, it's HTML statements, trtd, and at a C# expression, which gets added using add content. 1, 2, 3, and 4 C# expressions. 1, 2, 3. Okay, still on this weather.blazor source code file, we have the data that's for each over, which is the forecasts, this thing, this. And we also have this event implementation on initialized async, which is similar to a form create, form on show event. Let's see how it looks like. just this C# source code gets copied over to the pure C# version of the source code. Next up, let's look at HTTP routing. The route for counter.blazor is counter.razor is /counter. We can have multiple routes to the same Blazor component, such as like this. This change will require a restart of the debugger. Okay, so in here we say counter. It both navigates to the page to counter.razor, but it also updates the left-hand sidebar. It highlights the fact that we're on the counter page. Okay, let's go back to home. And now let's go to counter 2. Okay. This time the left-hand sidebar, the one with the tabs, doesn't know which of these three is currently selected, but it still navigates to the correct place to counter.razor. Next up, we will edit the HTTP URL. We want to capture a parameter that's passed via URL. For instance, we want an initial count, which is the number from which current count should start. Right now it starts from 0. Okay, initial count. This is the syntax. So we have parts of a URL path, and then between curly brackets we have a parameter that we're going to bind. Okay, let's see how we do that, how we get the actual value that's after the slash after counter, and how we get it into C# source code. So for that we need a C# public property of type string. Okay, so it's just a property with the same name as the parameter in the URL, and case insensitive. So you can have in here camel casing and in here Pascal casing, not a problem. Okay, and then we need Blazor magic, which is the attribute parameter, like this. Initial count, and we can use this initial count in here. If it's not null. Let's first just display it. Initial count is, and then we're using C#. Okay, let's see if auto-completion IntelliSense works in Visual Studio with Razor files. Control space. Not really. we build this thing? Initial count must contain a non-null value when exiting the constructor. Non-nullable property initial count. Okay, so that was a nullable reference types warning. It said that initial count must be non-null because I have declared it of type string, where it totally can be null because we're not initializing it anywhere except in here. So for instance, if we enter via the HTTP URL /counter2, then initial count will be null. Okay, so counter goes error 404 because we're using the URL /counter and then this part is mandatory. So let's put in here a number such as 3. And now we have this P where it says initial count is 3. If we use the other route /counter2, then initial count is null, which is string, which is a reference type, and nullable. So it's valid whatever is happening here. Okay. Next up, what we want to do is to make it possible to use just /counter and not provide a value for initial count in the URL, such that we do not have HTTP error 404. That's done by using the syntax in the routing line on line 1, which is the name of the parameter and then question mark. We'll need to build and run. When you run, it's automatically going to build. Okay, so it's counter and without anything. Initial count is a property and it's not assigned any value, so it's null. Let's look with ILSpy at this thing. So we're on the counter page. We have an initial count, as we would expect. Member uses the Blazor attribute parameter. Okay, and then inside build render 3, at the end we have this P. As we saw, the C# expression that's tied inside HTML is usually added like this: builder, add content, and then the C# expression. Okay, let's look at the syntax. So this is just a string that's passed to the constructor of route attribute. And then the engine, whenever it instantiates the counter class, which is a Blazor component because a web browser has requested a certain URL, will take the value from here and call the setter on the property if it has a value. and the type is string, so you can put anything in this URL path parameter. Okay, so we do not like the fact that we can put any string as an initial count. We can have, I don't know, A1. Okay, the initial count is there such that current count does not start from 0, but starts from another integer. So initial count should be an integer. There's syntax in the route attribute constructor, which will take from the URL initial count, but only if it's an integer. So this is the constraint. And now we can have the initial count property be of type integer. And this has the default value 0. So there's no possibility of nullability. Okay, let's build this thing and run. Okay, we did not specify any value for initial count, but because it's a property, type integer gets initialized to 0, which is what we see in here. The next step is to have the equivalent of the onload event handled, where we assign to the member field current value the initial count. Okay, so let's see how we do that. The event is named onInitialized. I'm not sure why the auto-completion does not work for me. The signature is protected. Override onInitialized and does not return anything. Okay, and in here we want current count to not start at 0, but to start at the initial count. Okay. Debug. It's already stopped. Build. And run. Okay. So initial count path segment URL does not exist. So it remains default value, which is 0. Let's give it a large value, 230. And now the current count is 230, and we didn't yet press the click me button. So let's press. Now the current count increments. So it starts with 230, and each time we click on the button, it increments from there. Increments in here and gets initialized to initial count in here. Okay, so I have refreshed in ILSpy. Let's see how onInitialized is implemented. So counter.razor gets converted to a pure C# source code, which is a public class counter of type component base, which is from the Blazor Microsoft.ASP.NET Core .components namespace. And in there we have protected virtual void onInitialized. And this is the synchronous version, and then there's the async version, onInitialized async. build render tree is also virtual. In here, protected override build render tree. Let's see what happens if we put a value for initial count or for the second segment in the URL. That's not an integer. Counter and then test. And what it does does return HTTP status 404, which means file not found, which means that there's no route defined in our application Blazor app for /counter/ something that's not an integer, such as the string test. So we don't have an error that initial count should be of type int and was provided of type string. We just, this just does not match this. So we don't have any route in our application that can match this URL, so we cannot serve any web page. Let's look at how the pure C# version is generated from .razor files for HTML elements. So we have counter.razor and the counter class. In build render tree, it says, so it starts with this line 5, page title. So page title is not an HTML element, an HTML tag, it's instead a component. So this is open component method. And as parameters, it receives the name of the Blazor identifier, the type, which will then be closed in here. So it goes open component, close component, and inside it adds the attribute child content counter. Okay, so that's for Blazor components. What about HTML tags? In there, it can either go add markup content or open element and then close element. Okay, so HTML is with open element, close element. Blazor components is with open component, close component. We have routes.razor, which is starting the routes, defining the HTTP routes. Let's go there. So Blazor app components, it's inside of this solution folder components. And let's see how this routes.razor file is converted to pure C#. So it's routes in here, public routes as we would expect. Component base, so the same thing for routes.razor as for counter.razor. Even if this page doesn't render any HTML source code. There's also build render tree. And then this is a Blazor component, this is a Blazor component, and this is a Blazor component, and this is a Blazor component. So it goes open component, close component, a ton. So open component router, close component, this part. And then it does component parameter app assembly. as it was for the open component add attribute child content. Okay. So up assembly, and then the value is type of program.assembly. So this C# source code is this C# source code. Okay. And then all of the children in at least in Blazor components are actually attributes. So found, this found is an attribute for router. Okay. Attribute name found with the context route data. What is that? Opens the component route view. This thing. Route data, this thing. Route data, this thing. Default layout attribute, component parameter. And this is the type of main layout. Close component route view. We're done with this part. And then open component focus on navigate and close it in here. So even if the Razor file does not generate any HTML that's visible inside of a web browser, because this is a Razor file and defines a Razor component, that Razor component will have a build render tree method where all of this Razor source code is going to get converted into open component, open element, close component, add component parameter, add attribute, etc. So these, I don't know, 10 methods of the render tree builder. Okay, so add component, add attribute, add content, add markup content, close element, close component. Okay, so what this does, it instantiates the Blazor component router, and it tells it to get the routes from all of the Razor files at page Razor lines and create a routing table out of the current DLL. And in here we have that functionality where when we navigate, the left tree view highlight changes from one place to the other. The URL routing is case insensitive, so you can write either lowercase counter or with an uppercase, whether all lowercase or with uppercase. Let's go to the next important file, which is the entry point razor component, which is app.razor. This actually renders HTML source code. Let's look at it. So it's under components and app. Okay, so all of these is just HTML. And then we have the first Blazor component, which says open component and then close component, nothing else. In here. And then more HTML, and then the second Blazor component routes open component and close component. And then we have blazor.web.js, which is one of the JavaScript libraries that are responsible for the Blazor framework inside of the web browser. So there's JavaScript magic running inside of the web browser when you're running your application for scenarios of type Blazor server only, Blazor server interactive, the long connection, the delta being sent over the wire from the server to the client with the delta between two versions of the DOM, the previous version of the document object model and the current version, the desired version of the document object model. And the signal are WebSocket. Okay. It uses Bootstrap CSS framework. We have a icon inside of the tab, so the favorite icon. Next up, we saw that the three Razor pages that we have, which is counter, home, and weather. The source code of these pages is really small. For instance, the home page. Only this part is contained in the home.razor file. And this is wrapped into these two rectangles, the one on the left hand side and the one on the top, which are called layouts. So we have two such layout.razor files where we have layout Blazor components. Okay, the major difference between the home.razor and the main layout.razor is that home.razor we can see in ILSpy inherits from component base, whereas main layout.razor has this razor line on line 1, where it says that it doesn't inherit from component base, but instead it inherits from layout component base. This thing. Which, yeah, it does inherit from component base, but in addition has this property named body. How that is being used, in here on line 14, we say that this is the wrapper around the home.razor. So this part will get inserted here. Okay, the same with nav menu. Let's see the nav menu. So this inherits from component base and does not use the at the body property. But instead, nav menu.razor is a Blazor component which gets inserted in here. So the actual rendering of slash involves this razor component, this razor component, this razor component, which is actually this razor component, and then in here it says that the main layout will be this one, layout component base main layout dot razor. In here we'll have the Blazor component nav menu, and in here we'll have the varying Blazor component. So if we're on home will be this one, if we're on weather will be this one. Let's now look at navlink. So there are a number of Blazor components built into the Blazor framework, which are very small and provide a bit of enhancement over a standard HTML element. So navlink enhances a bit the anchor A. Has href, similar to an HTML A, has class navlink, and then when it matches, we'll get another attribute which says active, which then you can use for CSS styling. Let's see that. So I click on weather, I inspect, and we can see navlink class, this part, but also the class active. Okay, it's just an A. That's what navlink is, an enhanced HTML tag A. Okay. By default, we specified that Blazor pages should use the as default layout the layout main layout, which is this one. That's just the default. So all pages by default have this main layout, but you can have different layouts. You can define a second class, a second file with extension razor with similar content to this one, which continues to say inherits layout component base, continues to use body, put whatever HTML you want around the body. And then, for instance, on the weather page, the counter page, you can say what layout it should use. So the default layout is main layout, but you can specify, okay, for all of the pages, continue to use main layout, but for just this one, for the counter, have a special different layout. In this case, it doesn't, the line 4 doesn't really do anything. The counter.razor already had layout, main layout as its layout, and now we're specifying it again. Let's now look at how to handle user interface web UI events. So we saw in counter.razor that on button on click, we call a private method that's synchronous, so it's blocking. Let's see how we can call a private method that's async. So that's sync task, and then this thing sync. Okay, and then we replace the method that gets called on the on-click event. Go to counter, and the button continues to function correctly as previously. So with an async implementation versus a synchronous implementation. Let's see how it works if the increment countersync method takes a really long time to actually return. We're going to await the task dot delay of a long time, 1000 milliseconds, so that's a whole second. Let's put a breakpoint in. Okay, so counter, and then we click on the button. It waited a second, and then it's going to increment. F5 to continue. So click, and then the increment happens. Click, wait a second, 3. Click, wait a second, 4. Let's see the difference in generated C# source code. So this is how it looks like with button on click increment count async. So it's a sender, this, and then the method to call. Okay, let's use back the non-async version. And now this part has been simplified a lot. Previously was with type task, and now it's just action and increment count. Okay, so one thing that we can specify in on click is a synchronous method. We can have an async method, but we can also have an inline function, a lambda. Okay, so let's look at that. One click, on click. So we don't have any parameters, and then the body is current count. And we're going to increment with more than one to prove that this lambda is called instead of one of these two methods. Let's build, let's refresh. And now there's the type action, but then in here we have this delegate part. So delegate, and then inside of a body there's current count plus equals to. So all three possibilities can be used for Blazor style event handlers. We can call blocking methods, async methods, or C# lambdas. Let's see the support in Visual Studio for auto-completion. So we're on the on-click handler. And in here, we know that we're not going to use a lambda. We're actually going to define a private method. And we know the name of the method. So let's start writing it. Increment count. We already have an increment count. So let's make this increment count 2. Okay. And then when it is showing the error, has potential fixes, you can go control dot, and says that it can generate either a method or a async method. And it also puts the correct signature for the function. Whereas in here we forgot to put the mouse event args argument. So we have handled the on-click event for buttons. Let's now handle other types of events. So we have an HTML input, and we want, as the text inside of the input changes, to handle the onChange event. OnChange equals, and then we'll have the wizard, the auto-completion, whatever, the Visual Studio generate the implementation of this method. Control dot, generate event handler. And in here, we have access to change event args parameter of this type. And we'll store in a private field the current text in the input. Text equals e dot, and then we have value, and this thing could be null and is untyped of type object. Okay. But we kind of know it's a string, might be the empty string. So let's cast it to string. And then we have this error converting null literal or possible null value to non-nullable. And we're going to tell the validator in the C# compiler that we know for a fact that value is not null and castable to string. Next up, we want to display somewhere the value that we have stored in here. We can have it into a P. And in here, we can say the current value of the text is, and then text. Let's see if this thing actually works. We can put a breakpoint if you want. Can we put breakpoints in here? Let's see. Counter. The current value of the text is. The current value of text is the empty string. Let's go continue. We have this input, and we'll make a change to it, add the character Z. I needed to exit the input. Now the value of the text that I have inside input is changed. It was the empty string, now it's Z, and the event on change has been triggered. Okay, let's see how E looks like. So has value, which is this Z. Okay, now in the private member text, we have the value Z, which is then applied to the P. Okay, so the current value of the text is Z. Let's look at the generated C# source code. Very similar to the mouse on click. We have the input on change. So it's builder add attribute. The big difference is that in here it specifies the fact that on change has a parameter, an argument of type change event args. So that's what action is. Action is a function that doesn't return anything and has just one, in this case with action of change event args, has one argument, one parameter of that type, in this case change event args. Whereas action without any generic type, it's just a function that has 0 parameters and returns void. So we saw previously when we run in the debugger that counter.razor has been run twice. So the line 14 in the debugger has been hit twice. First, just to render the page and send it to the web browser. But then when we exited from the input, we move the focus out of the HTML input, the event on change was triggered, and then Blazor knew that this method, the build render 3 method, needs to be run again. Okay, so for all of the events, once they are triggered, this and this and this, when these two are triggered, the build render 3 is going to be called again, which means that all of the HTML generated by the Blazor component will be generated again. That's why we hit with the debugger line 14 twice. The second time was after the input on change event has been triggered. Okay, so on change for inputs gets triggered just when you cannot edit the text any longer because the focus has moved out of the input, but we want to handle each character that's being typed by the user on the keyboard as characters become available. So that's another event for input, and that's called on input. Okay, let's rename the event handler. Control dot. Doesn't go like that. Forgot this one. Okay, the signature is the same for handling on input and on changed. It's change event args. Let's have this running. Counter, and now we're going to type the letter Q, and the breakpoint hits line 26. It's going to set the member variable text, and it's also going to re-render. So line 14 will be hit again. Let's remove the breakpoints. QWERTY. Let's type QWERTY. Okay, so the magic why this P changes is because this Razor file is being rerun. The build render 3 method is being rerun, and new fresh HTML is being generated, which means that the DOM in the web browser should look a bit different, and the difference between how the DOM should look like and how the DOM actually looks like at this moment is being sent to the web browser, such that the web page is updated, but just the text inside of the P is being updated, nothing else. This thing. Let's see more graphical user interface events. Let's have a div where we'll implement the events mouse over and mouse out. So it's a div, and inside of it we'll put text. C# member variable. Okay, And the div text actually starts by saying that the mouse is not inside of the div. Okay, and now we're implementing the event handlers on mouse over equals on mouse over control dot generate event. In here we're going to change the text mouse over, and we can have multiple events implemented on the same HTML tag. So we'll have at on mouse out equals on mouse out control dot, and we'll put the initial text back. Okay, let's stop the debugging, save and run. Counter. This is the div. We can put breakpoints in here. We can see how many times the razor is HTML for the razor is being regenerated by calling again and again the protected method build render tree. So one, have the mouse over event, and build render tree. And we also exited with the mouse in order to work inside Visual Studio. And we render again, build render tree. Well, you should just not have breakpoints when you're implementing such events that get triggered very, very often. Continue. Okay. Mouse over and mouse out. Okay, so until now we have just used razor events on HTML elements. How can we implement graphical user interface events not on HTML elements but on razor components? Okay, let's create our own very simple component. So we go components, right click on the components solution folder, add razor component. It's going to be named my button. Okay, so it contains sample HTML and a C# source code block. Okay, so let's create the razor component, not an H3 but a button. Let's have the text click me. And so this is HTML. When the user clicks on this button, we want a razor event. So add on click. on button click, control dot, have this thing be async, and we want the caller code, the code that instantiates and displays the Blazor component my button, to be able to receive the fact that this has been triggered and this has been triggered and this has been triggered. And we do that by interacting from this Blazor component to the exterior. So that's done with parameters and properties. So we have a public, and the type is event callback, and of type mouse event args. Let's give it a name. On click, so it's a property, has a getter and a setter. And the correct Blazor attribute, which is parameter attribute. Okay. Next up, so this is an HTML button. The user clicks on it. This method gets called. This is a sync, and we want if on click is if there's an implementation for this on click, then we want to call it. So that's done like this on click. So this event callback dot invoke async, and then when we click on the button, this gets triggered, this gets triggered, and E will have the correct value. So we want to pass the value of the E parameter further. And this returns the tasks. So we go there. Okay. But then whenever we have in a Blazor component the need to implement an event, we're always forced to have this extra private method, which just passes the event along. If we see that the type of onClick is actually exactly event callback of mouse event args, which is this exact same type. So we can simplify the source code by just having on the onClick event handler call the existing parameter property. We do not need the on button click private method any longer. Let's now prove that this Blazor component is what we wanted. Back to counter.razor. We'll add in here the Blazor component, so my button, and we have the on click. So this is the C# Blazor style event. Okay, and we can call, let's see if it works. So we're on the page counter and the final button is click me. If we click on it, it does the exact same thing as the first button, the one created by the Visual Studio Wizard for new projects. It looks worse because it's not styled yet. The event callback of type mouse event args, yet it's calling a method that returns void and has no arguments. And it works. Next up, we want that the caller of the My Button eraser component specifies the text of the button. Right now, the callee specifies the button text, not the caller. So we want something like in here, the second button, like this. How do we pass the value in here to the Blazor component such that it puts it in here? We do that using a special parameter. So parameter C# properties are the way in which arrays Blazor components communicate with the rest of the application. So we'll want a parameter, should be public, and then this scenario has been needed before, so it's about the fact that a button, an HTML tag button, has children, and this is a special children of type text. Okay, so the syntax is like this: render fragment, child content, get and set. Okay, and then this entire child content we can place instead of the text of the button, like this. So instead, in the HTML tag, we have add children, which is C#, and then this special parameter property, type render fragment, named child content. This is it, second button. Next up, what we want to this My Button Blazor component to know is to pass the rest of the HTML attributes that we put in here and just copy the rest of the attributes as they are and pass them into the generated HTML source code. Okay, so the caller does not like the fact that the first button is styled using the style of the web app, whereas the second button is not styled. So what the caller wants to do is to use Bootstrap to say that this button is class button and a success button. So we want to the Blazor component to handle this argument in a special way because it already knows how to handle it. But then all of the other arguments should be taken as are and placed into the final HTML. Okay, for that there's a special syntax in here. Yes, it's using a parameter. Let's stop the debugging. Okay, so the syntax is like this, parameter, and it should capture everything else. True. And then a property, special type, dictionary from string, which is the dictionary means a list of attributes and their value. So the string is the attribute name, and then object is the value. The name is also standardized, should be additional attributes. Get set. Parameter capture unmatched values true. Public dictionary string object additional attributes get set. And we want these additional attributes to be rendered here. So add attributes equals additional attributes. Button add attributes equals additional attributes. This should be it. Okay. And now the second button uses Bootstrap for styling. It's green because it's a success button. Next up, we'll take data from HTML elements, put it into C#, take it from C#, put it into HTML elements, and the same thing with transferring data from Blazor components to C# and back. Okay, so we have an input and a clear button that's going to clear the text inside of the input, and a paragraph where we'll have the text that was entered via the input. So we already know how to take data from the input, put it into C#, and then from C# put it back into a P. So that's done using event handlers from Blazor. So on change equals on change control dot event handler, where we put the text that we used previously. We have a private field named text. In here we need to put e dot value, which is a nullable object. Convert it to string, and it's not null. Okay, take value from here, place it into here, and then place it inside of the P. Let's see how this works. Counter, we have a input, We're going to enter the text hello. It's on change, only gets triggered when we finished inputting text, which means moving focus out of the input. So let's press the tab key. Okay. The on change event has been triggered. Inside text private field, we have stored the text that was inside of the input, which is hello. And then with this, the value inside of this field has been placed inside of the HTML element. Okay, that works. Let's see how we implement clear. So what we want to have is the clear button when we click on it. So we need to implement the Blazor event on clicked equals clear button click. This will set the text to the empty string. So back to the original value. And then the text that we display inside of the input needs to be empty. So that's like this. We're using HTML value equals, and then we're using C#. Okay. Hello again. Tab. Click on the clear button. Okay, this works, but it's a bit verbose. So there's support for implementing these idioms easier in Blazor. So what we have in here for the HTML input, we have both a setter of the text in here, and also we're reading from the text on change and store it into C#. So what we can have is bidirectional binding. The keyword here is bind and equals to the name of the C# variable text. Okay, so now when we say hello there, tab away, the text is taken from the input, placed into here, and then from here, when we press clear, when we press this button, this method is called, the text is made empty, and then because the binding is both read and write, bidirection is going to set the text of the input. This on change is not needed anymore. Tab and clear. Let's actually see how this is implemented in the C# part. We'll want to compile first. Okay, we got warnings for non-nullable reference types. We refresh. So we want to go to components, pages, raise counter, toggle all, and see how the input is implemented. So there's builder open element for input, close element, and then it's writing the source code for me. It's still using onChange. We did not have to write it. It's using a lambda where the value is being stored into the local variable, into the private member field text, and the value, similar to what we did previously, is being set to the text. So it's actually almost identical to what we had previously, where we set ourselves the value of input, and we had the implementation for onChange. We can see it's auto-generated because it uses stranger patterns like minus underscore value for the name of the parameter. So it just automates, writes the source code for us. The source code that we need to write ourselves. Set updates attribute name. Does this thing? I don't know. Okay, so Blazor has converted this short line 13 to a ton of C# source code, which is this thing. But we do not like the fact that, so as default, onChange event is a really good default, but we want the color source code to be able to say, okay, please don't implement onChange, implement another event, which could be, for instance, the onInput event. How do we do that? There's support for such a thing. The syntax is at bind, and then there's the name of the event. So colon event equals, and the name of the event on input. Build, refresh, and now instead of implementing the event on change, implements the event on input, and it runs as we would expect. Okay, so since Blazor is generating C# source code for us, there's various extension points such that the generated C# source code looks the way we want it for the given binding. One of the possibilities is, for instance, to specify a C# method that needs to run after the event has occurred. So the syntax is bind and then after equals. So let's say that the user has entered some data, and then we're going to search for that data. So search no. And doesn't have code generators, so we need to write the code ourselves. Okay, so we'll have a search that mimics going online, will take a long time, and will be asynchronous. So sync returns task. The name is this one, and we'll need a string member with the search results. Results equals empty string by default. First of all, we're going to announce that the search is in progress. Search result equals searching. Then we're going to await and mimic the fact that we're going over the internet and doing a search that takes a while. Task.delay 2 seconds. And then we'll have the result of our search. Let's use string interpolation. Found a number of results. Random dot pair dot next. Okay. So we have a member field empty by default. When the text inside the input changes, bind after search now. Let's put a breakpoint in here. The search result will be searching, and then after a while the search result is the actual search result. We're still not displaying anywhere the search result, so let's display it as a P. Okay, so the changes are these, this, this, and this method. We're going to put an A in here, just that. Waits 2 seconds. It wrote searching, and now the search result is populated. And if we put a breakpoint in here, we're going to see how the P has the text searching, and the text of the P will be changed to the value in the member field found a ton of results. Let's create a new Blazor component for a page, something similar to the weather. So we go right click on the solution folder pages, add Razor component. Okay. The name is to do. Okay, similar to the weather, it has a route in the routing table. which is called to do. And let's see if everything works. Okay, there's no entry in the left tool view in the navbar. So we need to navigate from the URL. So this is to do. Let's make it navigatable, this to do page from the left navbar. So that's layouts, main menu. This is the weather entry. We're going to create one for to do. So not weather, but to do. And the href is to do. Okay, so weather, to do. Okay, next up, we're going to have a C# class for one to do item. We saw similarly to inside of the weather razor. We can actually copy this thing. So that's private class to do item. There's a title for the to do item and if it's done or not. Control X twice. So that's just one to do item. We have an entire list, which is also kept in here. Do we have the same thing in weather.razor? Yes, we have it. This thing. Okay, to do item. Wrong auto completions. No name. Okay, so we have one row, one item. We have a list of items, and we can display them in HTML using a for each and, for instance, a unnumbered list. We already saw this thing before. Okay, so we have an unnumbered list. Inside we'll have a number of list items. For that, we're going to use the repetitive structure for each. We have one item. In to-dos. HTML. And we'll have C# title. Control S, hot reload. And we have a list of to-dos with just one item. We can create more if we want. Okay, so we can pre-initialize the list of to-dos either like this when we define the private field, or we can do similarly to how weather.razor does it in the onInitialized or onInitializedAsync, or we can have user interface controls which allow us to add to-do items. Let's actually do that. So we'll have underneath the to-do list an input and a button. So the input is with the to-do item title, and the button is for adding a to-do. Add to-do. So it takes the to-do item from the HTML, from the input, and stores it into C#. Okay. Next up, we want, when we click the button, to modify the to-dos private member variable. That's done with add on click equals add one to do, and we'll make this thing not sync. Okay, so we'll use inside of input, we will use data binding. For that, we will have a private member field type string with the title of the new to-do. Empty string by default. Okay, so add bind equals this thing, and the implementation of the event when the add to do button is clicked is going to be add another item to do item, and the title is this. Okay, and let's only do it if there is some content in this input and C# field. So if not string is null or empty or white space of this thing. Okay, after the new title is added as a new to-do item, we don't want to insert the same to-do items with the exact same title by accident. So for that, we're going to clean up this value. New to-do title is the empty string. Okay, let's see where we're at. Save and hot reload. Go to the park. Use the ATM. on click, add one to do. To do, use the ATM, add to do. So the binding is not done. Button on click, add one to do. Okay, so the issue is that this particular page, which we just created, todo.razor, is the debugger is going to go through it just once. It's preparing the initial HTML, it's sending that to the web browser, and that's it. This is just pure server rendering without any additional communication with the web browser. For those additional powers, we need what the counter.razor had, which is in render mode interactive server. Okay, so that means that if a button is clicked, then the server is going to be notified. The server has the state of the web page, knows how the page looks like. It's going to do the C# computations. It's going to connect to databases, etc. Prepare the new DOM, compare the new document object model with the existing document object model that's inside of the web browser, make a difference between those, and send just the changes to the web browser to be refreshed inside of the document object model. Okay, probably cannot hot reload this change. Build and go. To do. And now if we click on the button, the interactivity actually happens. So the interactivity being on click on the button and the bind, because the bind will do on change on the input, and will also set the value of the input. Okay. And now we have a bit of a guard because the input text is empty. Nothing will actually happen. But if we put non-empty, non-white space text, the source code will execute correctly. Now to-dos should have 3 items. Yes. The for each is going to be executed again. And also line 13 was executed again, where the value of the input has been set to the current value that's stored in the field new to the title, which is the empty string. Otherwise, there is the risk that the user will write some text and press the Add to Do button twice, and it will add two identical to-do items by accident. Next up, let's also use this member, to-do item.isDone. We'll make this list item more complex. So we want to have a checkbox for is done. So that's done with HTML input of type checkbox, and we also need to bind, and in here we can provide a valid C# expression. So that's to do dot, not to do, but one item dot is done. Okay, we could leave it at this. Now we have checkboxes, or we could also make the entire title user editable. Let's do that. So we want one item title, and don't specify any type, should be edit box by default. Okay, and now we don't really know what's inside of the to-dos. So let's put a breakpoint somewhere, but where? In here. Okay. So we have 3 items, all 3 have titles, just 2 are checked. We're going to create a new item, only such that the debugger will stop on line 31. Sleep. Okay. And now we can inspect the to-dos. So buy milk is false, correct. Go to the park is the second one, and it's true. Go to the ATM, true, and sleep is false. Correct. But we can also extract data from the to-dos and display it. Continue, remove the breakpoint, and we can, for instance, put a status, a summary of the to-dos, for instance, in the title of the page. So we can say remaining, and then how many are remaining. Let's use a C# source code. So to-dos dot, let's use LinkU, count, and then one item is done. So these are the count of items that are done. We want the reverse, the count of the items that are not done. Okay. And now if we check the sleep task, just one should be remaining. Okay, so each time we fire an event such as checking, the entire build render tree will be called again. Okay, so private class to do inherits from component base has the correct route. So the name of the attribute is actually a route attribute, but then the Blazor syntax is add page. And here we have the declaration of the local private member, this part. And in build render tree, we do h3, and then inside of a for each, we do this thing. I need to rebuild in order to be able to refresh ILSpy. Okay, a ton of content now inside of the for each. Previously it was just extremely simple HTML, but now we have two binds which are both two-way, which do both set updates attribute and the on change event with a lambda, and the, where are you? So this is the on change for the checkbox. This is the checked HTML attribute has the value of the C# expression one item is done. So this part here. Okay. So a binding has three parts where it does this. So to an HTML attribute or to an HTML child, it sets the value from C#, and then the on change implementation, and then this thing set updates attribute name checked. Okay, and then the same thing for the input of type text. The HTML attribute value has the value of the C# expression one item.title. On change and set updates attribute name